Assalamualaikum and hi, we are from Group 60 and today we would like to present our case study on the Teton Dam collapse. Dams are vital infrastructures that provide water supply, irrigation and flood control, but when they fail, the consequences can be catastrophic. One of the most significant examples is the collapse of the Teton Dam in Idaho, USA, a disaster that reveals critical engineering and ethical failures with lessons still relevant today. The Teton Dam collapsed on June 5, 1976 during its reservoir's initial filling. Seepage began 2 days earlier and by June 4, muddy water indicated internal erosion. Efforts to stop the flow using bulldozers and soil failed. On June 5, a sinkhole formed and the dam breached completely, releasing 300 million cubic meters of water. The flood, up to 8 meters deep, displaced 25,000 people, caused 11 deaths along with widespread destruction.
Hello, my name is Farhan and I'll be presenting about the technical and engineering issue. The 1976 Teton Dam failure highlights why strict engineering standards like Malaysia's Engineering Act 138 and Global Codes are vital. This shows the importance of professional responsibility, safety, and ethical practice for projects like the Bakun and Murun Dam. The first part of the engineering issue is the geotechnical misjudgments. Teton Dam was built on fractured, porous volcanic rock. Engineers underestimated the extent of fissures and voids. There were lack of detailed geotechnical surveys and incomplete grouting, which let water pass through quickly. The lesson here is to always conduct thorough site investigation and implement robust seepage control. Moving forward is the design deficiencies. The Teton Dam over-relied on impermeable clay core but failed to protect it from hydraulic pressures. It was poorly designed transition zones and lack of fittings led to internal erosion. The design didn't account for high hydraulic gradients when the reservoir filled. The lesson we can get from here is to integrate protective measures, proper material selection and consider extreme load scenarios. Lastly, construction oversights and lack of risk assessments. No detailed risk assessment or real-time monitoring during reservoir filling. Warning signs like leaks were ignored or underreacted to. No emergency action plan to handle rising seepage. The lesson we can get from here is continuous monitoring, early warning systems and contingency planning are critical. Grouting was rushed and not carefully monitored. Rapid reservoir filling increased stress on the structure. Poor compaction and insufficient construction oversight. Engineers Act stresses competent supervision, quality assurance and adherence to standards. The lesson we can get from here is to prioritize construction quality control and systematic monitoring.
Now I will briefly present Chapter 4 Ethical Reasons for the Failure of the Teton Dam, a case that highlights how ignoring ethical principles can lead to a serious disaster. The first major issue was the downplaying of critical geological hazards. During the constructions, engineers discovered that the foundation was made up of highly fractious volcanic rock, which is naturally unstable. Despite this, the project moved forward without significant redesign. A shallow and incomplete grout curtain was used, which failed to seal the fracture zone properly. Secondly, the dam design lacked a multi-layer defense system, and a safe dam should have multiple barriers to prevent total failure if one part is breached. However, the Teton Dam relied almost entirely on a single clay core. When erosion began, there were no backup system to slow or contain it. The third ethical failure was the lack of monitoring during the critical stage of dam filling. As the reservoir was being filled for the first time, signs of seepage and distress were noticed, but the response was slow and inadequate. No real-time monitoring system or contingency plan was in place to manage the unexpected behavior of the dam. And by the time action was taken, it was too late to prevent the disaster from happening.
The Teton Dam collapse highlights the need for a holistic safety approach. First, comprehensive geological assessment must be done to identify unstable soils and cracks before construction. Adding safety features like root curtains and internal drains and involving independent reviewers help reduce bias and structural risk. Next, real-time monitoring tools like piezometers, remote sensing and seismograph can detect early warning signs. Inspection should be done semi-annually with daily checks by trained staff. AI and drones can also help spot hidden defects. For reservoir operations, a slow and closely monitored filling process is essential. Spillways must be designed with saline basing and flip buckets and updated to handle climate-related extremes. Lastly, a strong emergency plan is vital, complete with evacuation routes, maps and public education. Multi-channel alerts and regular drills ensure communities can respond quickly if danger
In
arises.
conclusion, the Teton Dam failure was not due to a single mistake but a combination of technical and ethical lapses. It underscores the need for thorough geotechnical studies, strong design, proper supervision and continuous risk monitoring. For Malaysia, this case is a powerful reminder to uphold safe, ethical and resilient dam engineering in future projects. That is all from us. Thank you.